Thank you for joining us for today's webisode of the IPA Collective's Antibody Discovery Series. Today we'll be focusing on generating diversity through the use of different immunization techniques. In previous webisodes, we discussed the main problem we're trying to solve for our partners, or in other words, our main goal is always to produce panels of functionally superior and commercializable lead candidates in a fast and cost-efficient manner. But to add to the fun, let's be honest, almost all the easy targets have been taken. So we need to be able to do this against extremely difficult targets. IPA has a number of technologies, such as our in vitro display libraries and in silico services, that allow us to tackle these difficult targets, and those will be covered in subsequent webisodes. Today's presentation will focus on our immunization services, which along with quality tool generation is the first critical and technical component of an in vivo antibody discovery program. And we will discuss today how IPA can deliver consistent and target-specific immune responses to best set up a program for success. For the immunization pro and con list, I've broken it out into target categories of soluble and single pass and multi-pass. Soluble is a loosely defined category that would include peptides, small molecules, or essentially anything that is not expressed on the cell surface. For soluble or single pass transmembrane targets that have a recombinant extracellular domain, we offer both standard and rapid immunization timelines. First, for standard. The pros are the historical success, the relatively low reagent requirements, the reliability of the test bleed, and particularly in rabbits, longer immunization schedules are recommended for small molecules. The cons are obviously the extended timelines, and in some situations, depending on the species and strain, the organ usage can be less than ideal. Next, I'll move to Rapid Prime, IPA's high load tolerance breaking proprietary RIMS protocol. We find that we get a higher percentage of IgGs. It's a powerful tool in terms of breaking tolerance. It is good for conformational epitopes, and we find that we don't suffer an affinity loss even with a rapid 19 to 25 day timeline. On the negative side, the amount of reagents required is substantially higher, and the unreliability of systemic test bleeds after such a short time period must be considered. Next, moving to single pass and multi-pass strategies that do not have soluble extracellular domains to be used as immunogens. First is DNA. The pros are a native conformation, the high specificity of the immune response to the target, the tolerance breaking afforded from genetic immunization, the low cost and ease of reagent production, and finally the relatively rapid schedule of approximately 30 days. The negative of this is essentially the technical expertise required, whether it be gene gun, tattooing, hydrodynamic tail vein, they all require a level of expertise and experience to perform well. We also have to be mindful of any biological effects and the requirement for co-expression. The other mainstream option is cell-based immunizations or other native conformation expression tools such as VLPs. Obviously, this is an attractive option based on the native cell-based conformation and the ability to choose either synergistic or synergistic cell lines to limit your off-target potential or to increase the immunogenicity of the immunogen. However, the same balance falls into the cons by weighing the issues of potential morbidity associated with highly synergistic cells or the off-target issues associated with synergistic ones. In addition, reagent quality is extremely important in terms of native conformation, molecules per cell, and the timeline required to produce. And generally speaking, we also like to have a secondary overexpressing cell line or knockout cell line for screening. Just to prove we know what we're talking about, this is a breakdown of IPA's immunization experience over the past couple of years. Standard immunizations still hold the highest totals, though this is partially propped up based on its use in our rabbit B-cell programs for programs that require antibodies that are both highly specific and contain high affinities. Such programs are generally directed towards small molecules or programs for the purpose of generating IHC and anti-ID reagents. Next would be our rapid prime, which is generally where our cell-based immunizations also fall, then DNA, and then custom immunizations based off of our partners' recommendations. It's not surprising to see the majority of our multi-pass programs, in which our experience also includes GPCRs and ion channels, fall within the DNA category. As I've done in the last couple of webisodes, I'd like to jump into a quick case study highlighting the outputs from a couple of different immunization strategies targeting a B lymphocyte marker. The program design included immunization using an overexpressed cell line of about 150,000 molecules per cell and IPA's rapid prime schedule. In addition, we did DNA immunization delivered using our gene gun schedule in 5 different strains of mice. We then performed our semi-solid hybridomal workflow, followed by a multiplex flow screen against target-expressing cell line and its knockout counterpart. This was then followed by a secondary screen with an endogenous and rhesus ortholog to test for cross-reactivity, at which point top clones were then selected for sequencing. Looking at the initial test bleeds by flow cytometry at 1 in 1600, we can see a variable response based on strain, but in general we saw strong titers from both immunization methods. The key takeaway from me, though, was the strong target-specific immune response that was produced by the gene gun as opposed to the whole cell immunization method. Moving to the discovery program, we ran 4 separate fusions with 960 clones transferred for the cohorts that exhibited the best test bleeds, and 480 for the less responsive cohorts and whole cell cohorts that showed a strong, if not target differential immune response. Following the primary and secondary screening, we proceeded with sequencing of approximately 50 clones. From these 50 clones, the top clones with the most desirable characteristics on overexpressing, endogenous, and rhesus target expressing cell lines all came from our gene gun cohorts. And once again, in combination with the use of alternative strains, we've ensured a diverse number of germ lines as deliverables. In conclusion, IPA's multi-cohort approach using our industry-leading immunization schedules will deliver target-specific immune responses against even the most difficult target classes. And once again, when combined with our semi-solid hybridomal workflow, the result is a fast, efficient, successful, budget-friendly program. Thank you for your time, and we hope that you will join us next time where we will continue to discuss all things antibody discovery and development.